Hi, my name's Martin. I'm design engineer here at Energy Innovations. My job is to make sure all the mechanical elements of the installation work together and fit, to make sure that when we order the bespoke elements they are correct to the application. I'm also responsible, I have shared responsibility for calculating the heat loads on an application. I calculate the size of the fuel store and the fuel consumption rates for a system. I'm also responsible for CAD management and drawing release management. With regard to how I came to have this job, I was looking for a change in direction, and as if by magic, Energy Innovations were advertising in the East Anglian Daily Times. So I put in an application online, I was interviewed and subsequently offered the position, which I was glad to accept. Previously, I've worked in manufacturing. I have had a couple of other design roles, one of which was for a company called Flowvac Environmental, so very much in the environmental thing. And I've been here since April and going along swimmingly. I started my career at 17 as a trainee universal grinder, which for those of you who don't know is the finishing manufacturing process in the production of precise, usually hardened metallic components. A good example would be a pump shaft or say a stub axle. From there I've worked in several places in England. I've worked as a grinder in Australia. I've worked in America on machine tool remanufacture, which is where we would incorporate the ground components. And from that, I moved on to do a degree as a mature student, depending on your perspective, in product design and manufacture. Subsequently, I've done 2 City and Guild qualifications in AutoCAD and had a couple of positions as design engineer previous to becoming design engineer at Energy Innovations UK. Being a design engineer at Energy Innovations is quite a satisfying job. It's a warm, clean, well-lit environment. I work with a great bunch of guys. It's interesting. The actual area of expertise in which we work has got a good future, being a sustainable sort of heat source, energy source. And on the downside, nothing really springs to mind. It's quite a pleasant environment to be employed. If you sort of want to go down this sort of route as your career, the first thing is I think you need to be enthusiastic. Other things, if you lack a little bit in technical ability, if you're enthusiastic, you can overcome that. People will support you in that. They'll identify your interest and they'll bring you through. Obviously, to work with the computer-aided design package, a natural attribute for computers, I think, is going to be a huge help. And interpersonal skills are always a huge bonus. That helps in your immediate workplace with your colleague. It helps you relate with your clients and anybody else that you might have to deal with. And I would say that is the 3 main things. And attention to detail, that's always a benefit. And that probably covers the main aspects of attributes that are good for this sort of work. What does my work involve? Primarily, my colleague Mark Line will respond to an inquiry. He'll go out on site and interview the client and do a survey. He'll then feed that data back to me, and I'll turn that into a formal proposed drawing, as it were, proposed design. I take into account heat loads, fuel usage and fuel store capacity and all the other aspects that may affect the design. I pull that together on a program called AutoCAD. You can see a drawing on screen there. The blue entity there representing a 1.6 megawatt boiler, which is fed by what we call a walking floor, which is a system of teeth that move backwards and forwards and pull wood chip into a feed auger, which is set here, that then falls into a rising auger that feeds it into the back of the boiler there. From there you have a system of pipework and a control philosophy that feeds that into the entities to be heated by means of a network mains system. If I just then scroll through to here, you can see your walking floor here, draws the wood chip through this opening, falls into this cross auger. It'll then be brought up at an angle and drop into the back of the boiler. As you can imagine, there's an awful lot of money in these components, so it has to be right first time.